In this video, we're going to use correct notation to write the definite integrals and also to calculate the areas under curves within domains using the GDC. Example 5. Calculate this indefinite integral. Compare your answer with the value found for A in Investigation 1. I copied this from Investigation 1. Go back and have a look at it. Basically, they found the area was between 4.666 and 4.667. Now what this means, and you'll see in the investigation, that they did iterations. They built columns underneath the curve and they went up to 10,000 columns. This is the lower number here. This is where the column, the left-hand side of the column touches the curve, the top part, and this is where the right-hand side of the top part of the column touches the curve, or is aligned with the curve. So go back and have a look at Investigation 1, but basically we're going to find out from the GDC now that we can get an answer that's similar to that. All right, so it says compare your answer. So we're looking to compare our answer with that from the calculator now. We're going to go from the calculator. So I've moved the integral. Well, they put the answer here. In fact, that's their answer. And they said the answer was 4.67 from the calculator. This value is the same as the one found for A. So that's what they got from the calculator, and it looks very similar to the one that we got when we did the iterations in Investigation 1. The area under the graph of the function, x squared plus 1, we said that's the function between that stretched out s and dx. Between the vertical lines x equals 0, that's the lower limit, and x equals 2. Now, in using the calculator, they've got two methods. They've got a graphical method, and then they've got the scratch pad, or just the calculator method. I'm going to focus on method 2. So in your Inspire or the 84, you need to go to Menu, have a look for Calculus, and then look for Integral. You should find something like this with boxes. Where that 2 is, there's a box, there's a box. There's a box where the function is, and there's a box where the x is. You fill the lower limit in, and in our case it's 0. You just put these in the calculator. Then you put the 2 in, you write in the function, and then you put the x in, and you hit enter, and it'll give you the calculation, and that does match up very well with what was found in Investigation 1. Now, example 6 is good practice for the exercises that follow. That's why I've added this here. This came from previous pages of the book. It's basically the definition, how you see a curve and how you can write the integral. Because in this question, all you get is the curve. All right. It says write down the definite integral that represents the area of A. So here we have it here, and it's between 0 and 3. This is actually their answer, right? This is from the book. They've written their answer. And then they talk about how they got their answer. So that's the answer. Ignore these two, the lower limit and the upper limit at the moment, but we can see why that is in there because that's the actual function. Between the stretched out s and the dx, you put the function in. And then you have an x there, so it's dx. Now, how did they go to 0 and 3? How did they know that was it? Well, the question was, consider the region A enclosed between the curve. So the first step here is you need to draw the curve. You definitely need to put it in, draw it. You need to put it in the GDC, the function in, and have a look at it on the graph, and you'll see it looks like this. So if the question was, you have to do the region A enclosed between the curve and the x-axis, it's clearly this area here. Let me shade that in. Okay, that's the area we're looking for because that's what they asked us to find, that area. Well, to find that area, we need to know what that point is, which is obviously 0, and what that point is. Okay, the calculator is showing it as 0 and 3. But how do you find that? It says in this case, the lower and upper bounds are not given, but from the graph it can be seen that these are the roots of the parabola. Okay, now the parabola that they gave you was in this form. We know how to find the roots without using the calculator because the left-hand side would equal 0 because the x-axis is 0. And for that to be true, for the left-hand side to equal 0, the right-hand side has to equal 0. And there's two solutions. Either this x here equals 0 or this x here equals 3. Because if that x equals 3, 3 minus 3 is 0, so the right-hand side would be 0. If this x equals 0, 0 times whatever's in there would also equal 0. So the left-hand side would equal the right-hand side. The two roots are 0 and 3. That's the null factor law. Okay, just let me recap on that. There's two methods. With a simple function like this, use the null factor law, you can see what the roots will be, 0 and 3. Or just put it into the calculator, put in your GDC, have a look at it, see what it looks like, and then use the function, go to menu, analyze graph, and then find it, and then you can find the roots. Okay, it'll tell you the roots. Okay, so once we have that answer, then we use the calculator again. You go to menu, go to calculus, find the integral, and then just as we did in the previous example, you just have to put these numbers in. There'll be a box here, you put 0, you put 3 in, you put the function between that stretched out s and the dx, and you put the x in, and you should get an answer of 4.5. Exercise 13C, 1. For each of the following diagrams, 1, or I, write down the definite integral that represents the area of the shaded region. So we just got to write the integral. And I've added this. This was the definition that we got from the textbook that defines it. You need to write the integral, and this gives you all the information on how to write it. So you could write that here, write what the integral is. That's the first step. After you do that, find the area. So this is very similar to the previous example. Now for B, they don't actually have the function written, and there's no way to guess it. Just assume it's a parabola. Could be a parabola, right? There, just put it as y equals x squared and see how that works. All right, and do that one. It might not match the answer in the book. They might have had a different function, but let's not waste a great diagram. Okay, we've got another bunch on them over here as well. This is question 1 continued. You have to do the same thing. First thing is write the integral and then calculate the area using the function on the calculator. Again, I put this up here for you to remind you of how to do it. All right, you have to look for the limits. Now something like that, you can see that's between -2 and 0. This is between 0 and, how would we find that? Well, we'd find it the same way we did in the previous example. You'd have to use the calculator. You could put the function in the calculator and you could have a look at it on the graph there, and then you could use the analyze graph and find the roots. You could find that point. Or, again, it's a simple one. Factorize x out, and using the null factor law, you should be able to find out what that other root is. One of them is 0. What's the other one? Once you find that, you can do the integral. This one as well, it's the same as the example. You have to find out what those 2 points are. Put this one straight in the calc. Well, you don't have to. Again, you can use the null factor law, but you got the choice, right? Either put it in the calculator, have a look at it, and use the calculator graphics function there for finding the roots, or use the null factor law and just what can you put in this part here that would make that equal to 0, and that would mean then, remember the x-axis is where y equals 0, left-hand side is 0. How do you make the right-hand side 0? Well, either x plus 1 has to equal 0, or x minus 3 has to equal 0. Now, if x minus 3 equals 0, then x has to equal 3. So that looks like it's going to be 3. If x plus 1 equals 0, that part there within that parentheses there, then x has to equal -1, doesn't it? For that to equal 0, so that obviously is -1. Okay, you've got the two methods. And then once you get the integral, use the function again, the calculator function, go to menu, calculus, integral, and then put the upper limit, lower limit in, and the function in, and push the enter key, and you should get the area. Now, there's a bit of work here because they've got many exercises, many parts. It says number 2, in each of the following, write down the definite integral that represents the enclosed area, and then find the area. So similar to question 1 in a sense. Now it's just written. There's no graphs. This is similar to the previous examples. Y equals x squared, and you have to do it between that function, the x-axis, and the vertical lines x equals 2 and x equals 4. Use this to write it. That tells you how to write it and where to put the a's and the b's and the a's and the b's and how to put them in the integral there. Once you do that, use the calculator function to find the actual area by going to menu, calculus, and integral. So good luck with these as you go through. Okay, when you see intervals like that, that's the lower limit there, that's the upper limit. Okay, there's a lower, upper, lower, upper, lower, upper there. Here it's the same, right? We've got the lower limit and the upper limit. Here, and the vertical line x equals 1. So that's the function, and it says, write down the definite integral that represents the enclosed area. The enclosed area is that function and the vertical axis and the vertical line x equals 1. Okay, so the vertical axis is the y-axis and the vertical line x equals 1. So the lower limit looks like 0 and the upper limit is 1. Okay, there's more of these here. Same thing. It's still question 2 continued, but we've got f through to k. So have a look at these. There's the function there. The vertical axis is y, so that's x equals 0, right? The vertical axis and the horizontal axis. Now, how would you approach this one? The first thing is you really should look at it on the graph and see what it looks like. It looks like it's going to be an upside down parabola. It's going to cross the x-axis at 3 and minus 2. Minus 2 and 3. Now, that's how we did with the examples. But in this case, there's going to be two answers because we know the roots are going to cut at minus 2 and 3, and it's an upside down parabola. So if we wanted the vertical axis, that's a vertical axis, right? Basically, that's x equals 0, it's the y-axis. So you can have two answers here. You can have from minus 2 as the lower limit to the vertical axis, which is 0. So either minus 2 to 0, or you could do 0 to 3. Okay, you could have two answers because they're not really specific about which particular area they're talking about. But it could be either. All right. And good luck with these as we go through. That's straightforward like the example. It's an upside down parabola. The roots are 3 and minus 2 and the horizontal axis. So that's the whole thing from minus 2 all the way up to 3. Okay, and go through, have a look at these. This one here and the line. Okay, just put that in the calculator. Have a look at it and use the GDC to, once you put it in the graph, to find the roots of that. This one as well, put that straight in the calculator to find the roots. Now it's the vertical line x equals minus 1 and the x-axis. Okay, I've done that here with the Inspire, and this is actually the function, 3 minus e to the x. Now, if you want to put this straight line in, just to make it clear what area we're talking about, it's x equals minus 1. So what I did was, in the calculator, in the graphic function, I went to menu, I went to, what did I put in there? I went to menu, graph, entry, edit, which is number 3, and I went to relation, and I chose relation, and that allows you to put in a vertical line, x equals minus 1. So I put that line in as well, and that gave me an idea of the region. Now the region was x equals minus 1, and the x-axis. So because the graph comes around like that, I wanted to know that point. I used the function. Now remember, in the Inspire, actually, they don't call it roots, they call it 0. So go to function, go to menu, analyze graph, and 0, and then you can surround that and then find out that that point there is 1.09861. So that's the x value. The y value is 0, of course, because it's the x-axis at y equals 0. So we're looking at this area here, and you'll be able to calculate that if in your integral you go from minus 1 to this number, okay, not 1, but that number, and then you put the curve in, and then you can calculate it by going to the scratch pad or the calculator function of your calculator and put in the numbers for the integral and push enter, and you find the area that's enclosed by that. So it's obviously a great idea to put these more difficult functions, put it straight in the calculator, just see what you're dealing with. Okay, number 3, consider this curve, y equals minus x squared plus 4. Find the zeros of this curve and find the point where this curve cuts the y-axis. So what's going to happen is it's a piecemeal, which means there's two actual functions. There's this function here, but from 0 and less than 0, they've just got a straight line. So they join them together, but this side here is just the right-hand side of a parabola, and this first part deals with that right-hand side, and then they give you more information and they say there's also a horizontal line here. And then you have to find all of that area. You can do it piecemeal way. You can do this one, and then you can do that one, and you can add them together. So just see how they go through all this and follow it. Have a look at the other examples as well, and you should do it quite well with all the information that you know now. And I've cut and pasted the solutions from the back of the book here. Hopefully they're accurate, they're right, but just compare them as you go, and that would help you identify the ones that you're having trouble with.